Hi, Geometry. This is lesson 8A. So this is what you should be doing in in preparation for 8B when you see your teacher on your online meeting. So this is understanding slope ratios, and you guys should be able to find slope between 2 points and recognize equal ratios with the slope of a line. So this is, again, just a review to talk about slope. We've done slope between 2 points. We're just tying in all of our slope to triangles. So that's where I want you to be thinking. So to find the slope between the two red points, this is what I want this to look like. So obviously, these 2 points lie, these 4 points lie on a line, right? We know that they lie on a line. I just wanted to highlight the points themselves. So when we're talking about these, let's remember that they are all on the same line or a line with the same slope. So when we are finding the slope here, we're going to go up and down first, right? Left to right. 1, 2, 3 over 1, 2, 3. So we would label these sides of this triangle 3 and 3 because it represents the slope of this line. So here we have 3 over 3, and that slope simplified we know is 1 because 3 divided by 3 is 1. Okay, now between the blue lines, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 over 8. So we know that the slope of this guy is also 1. So what we want you guys to realize is that 3 over 3 is equivalent to 8 over 8, which is equivalent to 1, and that when we talk about them being sides of a triangle, we're really representing the ratio of the sides of that triangle. Okay, so go ahead and pause. Like I tell you guys in the other videos, just pause. If you've printed out the notes or you have access to the notes that we have given you guys, they are the slides that I'm going through now. So if you could do this problem on your own or re-sketch this problem on your own and then turn back on the video and see if you got it right and look for some ways where you could fix it if you got it wrong. Okay. All right, so as you can see here, I always try to go from left to right, which means that I go rise first, right? So up or down first. So for my red one here, I went down 2, which signifies a -2, and then I went right 4. So my slope here is -2 over 4. That simplified is -1/2. For my blue one, I have down 8 into the right 16. So that represents -8/16, which is also -1/2. So if we were going to represent the sides of these triangles in an equivalent ratio, we would say that we have -2 over 4 is equal to -8 over 16 is equal to -1 over 2. Next one. So now we have two separate lines that we need to look at. If we write the slope of the lines from the endpoints as simplified ratios, for our blue one over here, we would go down or up first. So we'll go down 1, 2, 3, 3, and over 1, 2, 3, 4. So we have -3 and 4. In our purple one here, we will go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8. Down 6 over 8. So we need to represent those ratios. We have, first of all, -3/4, which is simplified, right? I can't divide anything by the top that I could also divide by the bottom. So looking at our -6/8. Is there something I could divide the top by that I could also divide the bottom by? And the answer to that is yes. So we can divide this top by 2 and divide the bottom by 2, which is just simplifying a fraction, right? So then we'll have -3/4. And look at that. We have two equivalent ratios. Yes, they are equivalent. Does that mean the lines are parallel? So the ratios are equivalent, which means the slopes are equivalent, right? If I were to move, let's see if I can do that. If I were to move this line on top of this line, they should be the same, right? These are the same slope. So yes, they are parallel. How much bigger is the purple line than the blue line? So just to push your thinking, how much bigger is this purple line than the blue line? How much bigger is this -3, or how much smaller is this -3 than this -6? How much smaller is this 4 than the 8? What do you notice about the sides of the triangles they form? Do they have a relationship? So is there a way we could talk about this triangle compared to this triangle? Without knowing the exact length of this slope, right, of our original line, and without knowing the exact length of our blue line, how could we describe this blue triangle compared to this purple triangle? So those are questions I just want you to write down for right now, maybe jot down some ideas about, and then we are going to actually be talking about that in our class time. Okay, here's another one. Go ahead and pause your video at this one and see if you can complete this slide on your own. We're going to be talking about it in class, and then I will jump back on and give you some guided notes on that. All right, so here we are. We've got 2/5 and 6/15. So for the purple line, we went up 2 to the right 5, and for the blue line, we went up 6 to the right 15. So we've created these slope triangles, right? To represent the slope, we've created this triangle. Are these ratios equivalent? Would you say that these two triangles have the same slope for their hypotenuse? And the answer to that is yes. They do have the same slope. Like I said, I could move this purple line and match that blue line, and they do have the same slope, which does mean that indeed the lines are parallel. Now, what we want to think about for in class time is how much bigger the blue line or triangle really is than the purple triangle is. How could we talk about getting from this purple triangle to the blue triangle, and what is the relationship between these triangles? What's the same about them and what is different? We know this hypotenuse has the same slope, which is really the relationship between the sides. So 6 goes to 15, just like 2 goes to 5. And how do we get from one triangle to the next? What is the same? We want to be thinking about angles. We want to be thinking about what do we do to 2 to get to 6 that we can also do to 5 to get to 15. Okay? All right, we'll see you guys in synchronous class.